In question number 6, the acceleration of both the blocks are A1 and A2 with respect to wedges. Acceleration of wedges A1 and A2 shown in the figure are with respect to the ground. Then correct relation among A1, A2, capital A1 and capital A2 will be. So from the theory of constraint, if I call the length of this string is L1, this is L2, this is L3, L4 and L5, then summation of all the lengths Li must be equal to constant. So if I take the double derivative, then summation of A is equal to 0. Now if I write the double derivative of this segment, so that is A1, the double derivative of this segment becomes 0 as it is remain constant. So the double derivative of this segment is minus of A1 plus A2. The double derivative of this segment is 0 and the double derivative of this segment is A2. So this must be equal to 0. So on further solving, we will get A1 plus A2 must be equal to capital A1 plus capital A2. So option 3 is the correct answer. Let's move to question number 7. In question number 7, consider the arrangement of blocks shown in the figure. If forces F1 is equal to 2 Newton, F2 is equal to 35 Newton are applied on the blocks as shown, then the frictional force acting on 3 kg block will be. So if I calculate the common acceleration of the given system, then the common acceleration of the given system can be written as F2, that is 35, minus F1, that is 2, minus the frictional force acting at this surface in this direction. So the maximum friction is 28 divided by the total mass of the system, that is 7. So this comes out to be 5 by 7 meter per second square. Now if I draw the free body diagram on 3 kg block, then F1 is acting in this direction, that is 2 Newton. The common acceleration acting on 3 kg block is in this direction. So this friction must act in this direction. So if I write the equation F is equal to ma, then F minus 2 must be equal to mass into acceleration. So on further solving, the value of F comes out to be 29 by 7 into Newton. Now if I calculate the maximum friction possible between 3 kg and 4 kg surface, then F max comes out to be 0.3 into 3 into 10. So it comes out to be 9 Newton. Since the value of the applied friction is less than the maximum friction possible, so this case can be possible. So the correct answer for question number 7 is option 4. Let's move to question number 8. In question number 8, a particle of mass 1 kg is thrown with a speed 20 meter per second at an angle of 30 degree with horizontal as shown. Find average power delivered by gravitational force till the time particle reaches at its maximum height. So we know that the path of the particle is a projectile and this is the point when it reaches maximum height. This is h max. So the average power can be given by work done by gravity divided by time taken to reach this point. So work done by gravity is minus mg into h max divided by time is t by 2. We know that h max is given by u square sine square theta divided by 2g and t by 2 is given by u sine theta by g, that is the half of the time of flight. So if I calculate the ratio h max divided by t by 2, so it comes out to be u sine theta by 2. So if I substitute the data, the value of u is 20, sine 30 degree is half and divided by 2. So it comes out to be 5 unit. So if I substitute this data here, this is minus m, that is 1 into 10 into 5. So it comes out to be minus 50 watt. So option 1 is the correct answer. Let's move to question number 9. In question number 9, a particle of mass m is taken from point A to B with the help of a variable force such that the speed of the particle at the bottom of the curve is under root gh. If work done by the force F is 2mgh, then work done by gravitational force from A to B is. From work energy theorem, we know that work done by gravity plus work done by F plus work done by friction must be equal to change in kinetic energy of the particle. So the work done by gravity can be written as mg into h. Work done by F is given in the question, that is 2m g into capital H, plus work done by friction we have to calculate, that is equal to change in kinetic energy. So final kinetic energy is half m into v final square. So that is g into h minus 0. So if I calculate the work done by friction, it comes out to be minus 5 by 2 into mg into capital H. So option 3 is the correct answer. Let's move to question number 10. In question number 10, consider a rod of length L whose linear mass density varies with x as per this expression, where x is the distance from one end of the rod. Find distance of its center of mass from that end of the rod. So let's analyze the situation. Let L is the length of the rod. This is x equal to 0 and this is at x equal to L. In the given question, up to L by 2, the linear mass density is given by 4 L naught x, and after L by 2, it is given by 2 L naught L. Let the mass of this segment is m1 and the mass of this segment is m2. So we can find out the value of m1. So that is equal to 4 lambda naught x into dx, as x varies from 0 to L by 2. So if I solve this, it comes out to be lambda naught L square divided by 2. Similarly, if I calculate m2, so the linear mass density is 2 lambda naught L into L by 2. So this comes out to be lambda naught L square. Now, if I calculate the position of center of mass of this segment of mass m1, then let it is at this position, and I have to calculate what is the distance from x equal to 0. So x center of mass of m1 can be calculated as x into dm. So x is x into dm is 4 lambda naught x into dx. Integration from 0 to L by 2 divided by dm integration 0 to L by 2, which I have already done. So this is lambda naught L square by 2. So on further solving, it comes out to be L by 3. So its position is here at x equal to L by 3. Since it is a uniform mass distribution, so the center of mass of this segment is at the midpoint and its distance from x equal to 0 is 3 L by 4. Now if I write the center of mass of the given system, so the center of mass of given system can be written as m1 into L by 3 plus m2 into 3 L by 4 divided by m1 plus m2. So if I substitute the value of m1 and m2, then the position of center of mass comes out to be at a distance of 11 L by 18. So option 1 is the correct answer.